Hey, Ms. Cronin here. In this video, what I'm going to show you how to do is solve quadratic equations by factoring, and then we're going to reverse that. We're going to find so we'll be finding the zeros when we do that, and then we'll reverse that. If you're given zeros, how do you find the function that's associated with those zeros? Okay, so let's get going. For your notes, in order to find the zeros, you should pause this video right now, and you should pause the video right now and write down steps 1 through 4, and then I will show you how we go through those steps in just a moment. All right, so step 1, you're going to replace f of x or y with 0. So I'm going to write 0 instead of this f of x, and I'm finding the zeros, which means I'm finding the value of x that makes the y-coordinate equal 0. And so graphically, you're going to see that these are your x-intercepts if they are real zeros, which we'll talk about complex zeros in another future video. Okay, so step 2, we're going to factor this function. So remember, it's a trinomial. It's going to factor into 2 binomials. And the first 2 terms have to multiply together to give you x squared, which has to be x and x. And then the numbers that go here have to multiply to 12, and they have to add to -8. So my factors of 12 are 1 and 12, 2 and 6, 3 and 4. The only ones I'm going to be able to get an 8 out of is 2 and 6. 2 times 6 is positive 12, but it adds to positive 8, not -8, which means both of these are going to need to be negative. A -2 times a -6 will give me that positive 12, but when I add the outside and inside together, I'm going to get a -8 instead of a positive 8. So it would be x minus 2 and x minus 6 in factored form, and you guys can FOIL that to double check to make sure that that is equivalent to the original expression. And then, let me get this problem out of the way. Now what we're going to do, since we have 2 things multiplied together that equal 0, then by the zero product property, x minus 2 equals 0, or x minus 6 equals 0. And so solving this, I'd add 2 to both sides and I get x is 2. Or if I solve this one, I add 6 to both sides and I get x is equal to 6. So then we should check that to prove that it actually does work and that it does make it equal to 0. So I'm going to find f of 2. F of 2, I'm going to plug 2 in for x, so I get 2 squared minus 8 times 2 plus 12, and I should get 0 if it's the correct answer. So simplifying that, I get 2 squared is 4. Hold on, see if I can do this. 2 squared is I'm going to have to go over here. 2 squared is 4 minus 8 times 2, which is 16, and then plus 12. Now make sure you do your order of operations correctly. 4 minus 16 is -12. -12 plus 12 is actually 0. So why don't you check x equals 6 to make sure that that is indeed the solution. Okay, so I'd like to do another type of factoring here. I'm going to just do a couple of examples here. I'm going to leave those out. Let's do, oops, this is not the one I want. I want to do this problem right here. So what we're going to do is we're going to follow those steps. Step 1, we're going to replace, instead of f of x, this time I have g of x, which just represents y. So we have 3x squared plus 18x. So think to yourself, what's different about that quadratic versus this quadratic? Well, there's a couple of things, but one of the major things is there's no constant term. This 12 is a constant term, and if you notice, there's no c term. This is, if you're thinking standard form, the ax squared plus bx plus c, the c is not there. Actually makes this problem a little easier. What you're going to do when you have no, the first thing you should always do in your factoring is look for common factors. And we have a common factor of 3 in both 3 and 18, and we also have an x common to both. So I'm going to factor out a 3x, and what's left in the parentheses is each of those terms divided by 3x. if I have 3x squared and I divide by 3x, I'm left with just an x. Or another way to think of it is factoring out a common term is the reverse of distributing, the distributive property. So if you think, okay, if I pulled out this 3x times what would give me 3x squared? It would have to be another x. And then what would you have to multiply 3x by to get 18x? And that would be 6. So factoring out a common term, always think of doing that. That's the first step always when you're factoring, is see if there's anything common to all the terms. All right, and then we have 3. We can just consider this the whole one of the factors, and then this is another factor. And so if I set 3x equal to 0, divide by 3, you get x is 0. That's one solution. Oh. And then x plus 6, so I can write or, x plus 6 equals 0, and if I subtract 6 from both sides, you get x is negative 6. Go ahead and check both of those in the original, and you'll see that they do indeed make the equation equal to 0. All right. There's a couple special types of factoring that are good to be aware of, and we talked about this in class. But a difference of squares, a difference of 2 squares, will factor into the square root of a, goes here and here, and if it's minus, and this minus, that's what difference means. It has to be a difference. If it's not a difference, you can't, it's not factorable. You factor it into a, the square root of a squared, which is a, and then plus or minus the square root of b squared, which is b. So an example of that, let me start a little easier. This is a little bit complicated. Let's say that you have x squared minus 25 equals 0. So notice that middle term, the b term, or the x term, is not there. It's just x squared minus a constant. And so there's a couple different ways to solve this, but one of them is to factor it, and knowing that it's a difference of squares, I want you to automatically just know it's going to be the square root of x that goes here and here, and then the outside and inside have to add to 0x. So you can think, okay, what are factors of negative 25 that add to 0? Or you can just know it's going to be the square root of 25. You're going to add it and subtract it, and then this just showing that this actually does work. X times x will give you that x squared. The outside is 5x. The inside is minus 5x. 5x minus 5x adds to 0. Negative 5 times 5 gives you 25. So that is the same thing. X minus 5 times parentheses x plus 5 is exactly the same thing as x squared minus 25, but in a different form, called factored form. So then what do? You set each factor to 0 and solve each of those. And you get x is 5 here, x is negative 5 for that one. Okay, now one more thing that I want to do. I'm going to leave some of these more complicated ones. I can come back to that in a different video, but let's work this backwards. Suppose a quadratic function has zeros of 4 and negative 7. Write the equation for the function. So if my zeros equal 4 and negative 7, what are the factors associated with that? So let's think like we had x plus 5 and x minus 5. When we solved each of these, x plus 5 equals 0, we subtract 5. We got a 0 of negative 5. But now think about the associated factor with that. If this is the 0, the factor is, you're going to, if you have your zeros, what you're going to do to find the factors is you're going to take x and subtract the 0. So x minus a negative 5 becomes x plus 5. And then when you set the x minus 5 equal to 0, we added 5 to both sides, and we got x equals positive 5. So that this is the 0. If that's the 0, then what you do to get the factor is you take that 0, you go x minus that, and that's the factor associated with that 0. So when you need to find a quadratic function whose zeros are 4 and negative 7, you're going to, it's a function, so I'm going to write f of x. And if 4 is the 0, then the factor is x minus 4. And if this is if negative 7 is a 0, then the factor is x minus a negative 7, which becomes x plus 7. And foiling that out, and this is a function right here, and it's in intercept form, but let's put it in standard form by foiling it. You get f of x is equal to x times x is x squared, plus the outside is 7x, inside minus 4x, and then the last two is minus 28. And then this is my function. I'm going to combine these two terms. That is plus 3x minus 28. So x squared plus 3x minus 28 is a function whose zeros would be 4 and negative 7. And you can check that. Let's set it equal to 0. How do you find your zeros? Well, you would factor it. And if we factor this, it's going to be x and x. And then factors of negative 28 that add to 3 are minus 4 and negative 4 and positive 7. So one factor is x minus 4, the other factor is x plus 7. And then you would set each of these equal to 0 and solve. And here we would get x is 4. That's the 0 associated with that factor. And here x is negative 7. That's the 0 associated with this factor. Okay, so that is how you find a quadratic function for a given set of zeros. All right, so let's do one more example. Find a quadratic function with zeros of negative 6 and 2. I want you to pause the video. I want you to try to do this on your own. Come back and check your answer. Okay, so first thing you want to do is you take your 0 and you're going to go x minus that 0. And so we have x minus negative 6. And for this 0, we're going to go x minus 2. And then we're going to multiply those two together. First, let's minus a negative 6 is plus 6. And then if we FOIL that, x times x is our x squared. Outside is minus 2x. The inside is plus 6x. And the last is minus 12. And then combining these two, you'll get 4x. So the function is x squared plus 4x minus 12.